There we go. All right. Hi, everyone. Welcome to the Teach Pickleball meeting for Wednesday, February 28th, 2024. So I've been working my way through my backlog of patches. Some of you may have noticed I've been spraying a lot of patches onto the list recently. Good news is most of them are going in, so that's great. I've got a few more I'm currently working on, just trying to get those out. Yeah, I've got a lot of file system work that's currently stalled. Some of it needs to be redone. I've got some review comments to go through, but the side of the work I'm doing is mostly taken care of at this point. I got the NilFS patches were already in. I've got the UBFS patches in. ButterFS I have been negotiating with. It seems that the developer who was working on didn't quite understand how folios were supposed to work. They thought that the folio index was done in terms of the folio shift rather than in terms of folio size rather than in terms of page size. So once that's cleared up, that's going to be a big improvement. I just kicked off a discussion about CMA. That's the contiguous memory allocator. I believe that I hadn't really been thinking about CMA very much. And then one of my colleagues decided to send a patch which really had only changed the type. There's the type return from being a struct page to a struct folio. It didn't actually do anything else. And when pressed, he said, "Well, I've made it return an array of order 0 folios," which is I mean, it's true, but it's really kind of not the spirit that folios are intended to do. You know, we're supposed to have one folio per allocation rather than returning an array. So I've started a conversation with the maintainers of CMA. I haven't had any responses yet, but just trying to figure out, you know, what we should be doing in the Memdesk future. Let's see. I have a few right page conversions still in my tree that I need to send out. We've got most of the right page. The file systems that use right page have been removed. Oh, Christoph Helvig's adoption of my my right back iterator is now in Andrew Morton's tree, so that's great news. That should help things. I think Dave Howes is going to have a couple of things to say about us in a minute. Yeah, there's a lot of work gone into the Andrew's tree recently, so that's all really good news. Yeah, I'm just working on page cache iSize extended, which is currently using struct page, and I think it's a pretty straightforward conversion. Use struct folio. I am going to send it out to the file system people because I think there's. I want to be sure that I've understood it correctly because it skips as long as the block size is greater than or to page size, it skips doing any work at all, and I just want to be sure that's right. So look out for that on the file system list in a few in a few hours. All right, I think that's about it from me. Let's see. Yan, you've got a bunch of patches then. Do you want to go next?
Sure. So first, my greater than order 0 folio compaction is picked up by Andrew, so that's great. Next, the sooner it's sooner than I expected. The split page to any low order also picked up by Andrew, so that's also great. So I think for that patch, I think it just and I had discussion with Hugh and Ryan. I think this is just the first step, since it's only splitting into a single order, and they give good examples, splitting to multiple different order of smaller folios might be good for performance. Say truncating a single 4 kb page out of a 2 meg, you don't want to just split all the way to 4 kb, but it's better to like say order 8, 7 until order 1 and removing that one. But I'm still I leave that as future work, since there'll be more complicated things doing there, and I don't know how that will work in terms of like splitting operations, since I remember in the X-array used in the splitting I need to specify an order, but I don't know if I split into multiple different subpages how that would work, or how should I operate in that case. So basically, the I pages, yeah.
I think in that case, you're going to want to do multiple X-array operations. You're first going to want to split the X-array entry to order 8, and then split one of them to order 7, and then we're going to split one of those to order 6. I don't think we want to have an X-array operation where we say, well, we're going to turn this into this stack of different sizes. That seems a very complicated interface to imagine and to work with.
Okay.
So
but
I actually wonder whether we want to push that all the way up, right? Do we want to say no? You like split page that only does to one side. So if you want to do this to 8 to 7 to 6 to 5, that's multiple calls, and you just keep splitting until you get down to where you want to be. Maybe I don't know.
So since I'm just thinking if that can be done after I unmap all those pages, unmap the page, right? Because that's the direction I want to go is unmap all the mappings. Then I do the splitting like recursively or multiple iterations. Then I remap them individually. Otherwise, if I do unmap, split, remap, and unmap again, there's a lot of TLB shootouts. That's the thing we definitely want to avoid, and that's also the reason I didn't do that in the first place.
Right. Well, do we remap it? Because I thought we just allowed page faults to then come in and start faulting on it. I didn't think it would. I didn't think we put it back into the page tables.
I may remember it. Yeah, probably I didn't. Yeah, there is the remap page. Oh, that's failed pass. Okay, right. I probably I think code change in the past. So yeah, I think there is no remap, so it's only unmap. Yeah, that's good. Yeah. So unless someone someone asks for it, I won't do it right now. So I'll just see how it goes for the simple ones. So that's for the splitting part. You just sent us the email about you're here. So would like to discuss the 1 GB THP support. So I'm curious to hear about the use case, and I already sent out the to-do list for that to adding 1 GB THP. So basically, there are two parts. One is the allocation part, and what we can do to allocate 1 GB page from the body allocator, because we need some changes to body allocator, which is limited by the max order, which is in turn limited by the section size. And we don't want to increase section size, so which means the max order will go beyond section size, and there will be additional checks in the body allocator page merges, because it go beyond a section size, so there is some page may not be available, or there is a hole in the zone. There will be more checks when we do merges up to the page order beyond back section size. There's one part. The second part is the fragmentation. since currently page block size is 2 meg, which means we're optimized for 2 megabyte, like 3 pages. How we can get over that to go beyond that and go to 1 gigabyte 3 pages? There's another thing. So that's the first allocation part. Second is the actual 1 gigabyte THP implementation part. Is how transparent we want it to be, because currently the 2 meg THP can support like double mappings, mapping subpages, and all kind of splits. For 1 gigabyte, I'm supporting like triple mapping seems crazy, as I did it before. There are a lot of hacks here and there, and also the page map count is changed, and there will be I will add more complexity into the existing code base. I don't think we want to do that. And also, David Hildenbrand is working on his project to trying to use it to remove the total mapping or kind of per page map counts thing. So I don't know how I will need to talk to David to see how we can work his plan into this 1 gigabyte THP implementation. So yeah, since Yujao is here, I would like to discuss with him and see how what actual requirement for the 1 gigabyte THP you would like to add there.
Sure. Yes, that's why I'm here. And first, sorry for missing so many meetings. uh, um, yeah, we at Google have solved most of the blockers that you just mentioned. So the first one you said, how do we allocate? Are we gonna allocate 1 gigabyte pages? No, from page by the allocator. So this one, actually, we here's how we did it. First, we tried to make page block larger, and then it was proven to be a not very good solution. So what we did is we created a new we made a new abstraction, right? We have you know normal zone, DMA zone, and high memory zone, right? So those are physical properties. Those zones are decided by physical properties. But we also actually can make virtual zones, or to be less confusing, policy zones, right? This is an abstraction that on top of physical zones, right? We want some zones to have only software policies. They have nothing to do with physical properties. So the mobile zone is one borderline example. So yes, it was first created for hot plug, right? But we also use it for CMA and um, capture kernel, key dump capture kernel, right? So mobility is actually not a purely physical, or you can say it's not a physical property at all. It's more like allocation policy or allocation time property, right? Because it's decided by GFP, one GFP flag, right? So another allocation time policy or property is the order. So when you allocate something, you have to give GFP flags and an order. Those two are required. So based on this, we can make new abstraction, which is a new zone. This zone has specific order, right, on top of mobility.
Right.
So because why on top of mobility? Because zones are supposed to be able to fall back. A higher zone must be able to fall back to lower zone. That's why if you try to get a get a page from high map, if you can get it from normal, right? Similarly, if you try to get a high order page from this new zone I just talked about, if you cannot, you can fall back to the mobile zone. But of course, the mobile zone might be too fragmented, or might not have enough free memory, whatever reason, you might fail. But the first zone you tried, the new zone I talked about, gonna give you really high guarantee or high um, probability that you're gonna succeed with the allocation. That's how we solve this, 1 gig page allocation problem, right? Because based on this, I think you can infer that there isn't fragmentation problem at all because it's fixed order, so, right? So
Right. So are
but
you saying does the page still coming from the body allocator? That's something you are thinking about, or you want something to different. You have dedicated allocator for that
it's a from
additional zone.
body allocator, but it's from a new zone.
Okay.
This zone does not have
Okay.
fragmentation, and this zone
Right.
only give you specific orders.
Right. So basically, there is no actually body. It's just like tons of 1 GB free pages, and you ask for it, and you get it. You don't split.
There are bodies. You can go to 2 meg,
Okay.
you can go to 4 meg, but you cannot go below one. Sorry, not 2 meg. You can get 1 gig, you can get 2 gig, you can get 4 gig. For example, if the minimum
Right.
order is 1 gig, you can get at least 1 gig, right? You cannot get anything
Okay.
below 1 gig. You can get 2, 4, or 8, but not 5, 12 meg or smaller.
Right. So for that part, I'm just thinking how you're going to carve out Zoom at the boot time, since the physical address is not. You have to enforce Zoom has to be 1 GB aligned, right? Otherwise, you will see that's something we need to think about when we build the Zoom at boot time, so it wouldn't cross.
That's implementation details. It doesn't matter. Just as long as the concept, because we have limited amount of time, so we can talk. So this is something I plan to talk about at SFMM. We can discuss this more, but the concept here, I think, I want to make sure is clear, right?
Sure.
So we can make sure it's aligned. We can make sure there are no holes within this zone. We even can make this zone dynamically resizable. Basically,
Right.
you can offline pages or online pages, offline pages from this zone and move this offline pages to other zones, or you can online pages from other zones.
Right. So it sounds like it's something similar to what the huge TLBFS does at the runtime to allocating 1 GB free pages there, right? Just like now you have defined zone there, but in the huge TLBFS at runtime you just echo into the system control, and they're just using the config pages to allocate those ones. And since you want,
let me interrupt you. No, yes, I got this. I got asked about this question many times. The answer is no. Why? Because if we talk about 1 gig pages, you might think yes, right? Or there's some similarity there. But if we use, let's say, we use it for 2 megabytes THPs, is completely different. Why? Because let's compare this design with the huge TLP-FS in terms of 2 meg, right? If I cannot get it from this zone, or this zone is like no free memory there, right? I can do 2 things. First one, I can reclaim, because this is just no more page, right? I can just reclaim. Second one, if I, let's say, or 2 meg THPs in this zone are hot, right? I can fall back to the next zone, which is the mobile zone. You might be able to do some compaction and reclaim and get it to Mac, right? So that's the fundamental difference there. So everything is seamlessly, transferred into this zone, the core mem features. That's fundamental difference. But with huge TLBFS, you cannot reclaim. You cannot fall back.
Right. Yeah, that part, yes. I think
also you cannot migrate. There are fancy features that I can tell you. So if this zone not supposed, if cannot split, what are we gonna do when we split?
Right.
So this is something we call THP shattering. Basically, instead of splitting is in place. Okay, splitting is not the exact reverse process of collapsing. Right? Splitting in place. Collapsing is like I grab a bunch of 4K pages and I migrate them into a 2 meg THP. So splitting is like I do it in place. But also you can do the exact reverse process of collapsing. You can migrate occupied subpages into a bunch of 4K pages. That's what we do with splitting. We call it shattering.
Right.
Also,
yeah,
we
I
have
think
okay.
I agree. This kind of sounds more doable in terms of like 1 GB THP. And yeah, there will be some details to nail down since like you said, resizing the zones. I think Johannes, he also has some like he has some collaboration with like CMU people. They have some similar idea like resizing the zone and allocating huge pages from there. One question I had always had in mind is if there is some like
Was that
unmovable pages.
sorry? Was that posted somewhere? I didn't remember what you mentioned. It's like from you, because I can look at
I think there is
yeah.
there is a paper they collaborating. Let me send you it in the chat.
Okay, that'd be nice. Thank you.
Yeah, so there are similar things, but what I have even David Hildenbrand mentioned this when way back when we're discussing like allocating 1 GB pages. Is like he had, oh, let's have a zone